the right keyword in Fndlang is used to create identifiers. Identifiers are code syntax that the programmer could write themselves, and later on in the program they could go ahead and reuse those identifiers to make things, way more easier to write and understand, basically. To start writing identifier, you would use the keyword write, and then you'd use the opening and closing curly bracket. In the bracket is where you'd put the code syntax that you want, basically, and then you have the function body, which is where you'd write the code of the identifier. You can also have value placement, which is by using the @ symbol and then the name of the variable. If you have a space after the @ symbol, this is not going to be a variable. This is just going to be a keyword placement. So keyword placement are words that you could have for your code syntax, basically, for your identifier. That is what keyword placement is. So there's a value placement, which is when you're using the @ symbol, and then there's a keyword placement, which is when you just put the keyword, basically. The word, any word you want. So it could be like create some, right? Create some. So that for this identifier to be executed, I have to call the create sum, and then I have to put 3 value placement. So that would be something like create sum 1, 2, 3. So this, when I run this code, it's going to call this identifier. That's because that is how it's written. That's how the code syntax looks. So value placement, when the compiler compiles them, it basically replaces those value placement with the values that I've given, which is 1, 2, 3. So if I do something like this without space, create sum 1, 2, 3 without space, this would be create sum, and then all this number 123 will be sent to variable name, which is the first variable placement, value placement. The other ones will not have any values. Therefore, this identifier is not going to be executed because it doesn't match the code syntax. The code syntax says it has to have 3 value placement, but in this case, I'm only passing 1 value placement, which is for variable 1. So if I wanted to pass for the other 2 variables, I would have to put space, and then that would work. But if I put something like 123 space and then 31, that would only be for these 2 variables. So the other one is missing a value placement, so this identifier will also fail. So that means you have to put another value, which is for this one. So that's how you work with identifiers and call them as well. So yeah, keyword placement is the word that you would have to call it with. So if I had create sum, and then I had value placement, and then I had space X, this would mean if I wanted to call this, now I have to do something like create sum, give a value placement, add an X, and then give another value placement, and then another value, which is that. So this here is the same thing as this. That's what the identifier code syntax looks like when the programmer writes it, basically. And if you want to have references has a value placement, instead of just adding, having like copies of the value has a value placement, you could also require a reference of the value, basically. So you could tell the identifier that this value placement should be a reference. The way you do that is by using the raw string. Then after the raw string, you would add the inside of that raw string, you would add the ampersand. The ampersand is how you tell the compiler that this value placement should be a reference. And if it's not a reference, the value placement is going to be pointing to a non-value, which is null, N-U-L-L. So yeah, that's how you would require value placement. I mean, a reference value placement. Yeah. And then let's say that you do want a reference value placement, but it's not required. It can also be a copy of the value placement. You could do that by adding the question mark after the ampersand. So that tells the compiler that this can be either a reference or a copy, basically, of the value as a placement. So this is always good to have. I recommend using this optional reference value placement. I recommend using this over the reference, because this would mean when the value placement of the required reference, if the compiler cannot make a reference of that data, it will return a null back. So this would mean if I try to use variable name, the output of that would be something, null, because the compiler doesn't really know if this is actually a reference. So this only happens on compile time. So I mean on runtime. It's when it's that's when it's gonna be able to like make a reference of this thing, of this data that we're passing. So if we're doing something like 10 is not a data that could be used as a reference. So this is going to this 10 output, this 10 value placement is going to return null because we're requiring it to be a reference. But if you're using the optional reference, this would mean the variable could either be the 10 value or it could be the a, which points back to 10. So if I give it 10 or if I give it a, it will basically work on the appropriate way. So if you give it a variable that can make a reference to it, then that is what it's gonna use. It's gonna use a reference of it. But if you give it a constant value, meaning that it's something that cannot be referenced to and cannot be changed, then that would mean it would use the optional. So this would mean the value is still gonna work. It's just gonna have a copy of that value, so it doesn't return the null output back to the variable. That is what the question mark does. It's just a reference, optional reference value placement. And here, after the curly bracket, we're using the raw exclamation point inside of it. This makes it so the code, the identifier, is only going to be executed when it's being executed on the far left side. So this means something like this. This is where you'd write your identifier code. So I'm just gonna do someth. So that's that, right? So if I do something like log someth, which is the identifier that I'm trying to write. So if I do something like this, this identifier is not going to execute. The reason is because for the someth identifier to be executed, it has to be on the far left. But in this case, we have log has the far left, and then we have someth on the the far right, basically. So for someth to be executed as an identifier, it has to be the first on the far left, basically, for it to work. And the reason why this is the case is because I'm adding this this parameter here, which is telling the compiler that this can only run if it's being executed on the far left and not on the far right. So this means if you pass it in a function call, this someth is not going to execute as an identifier because it's not on the far left, so it's just not gonna it's just gonna return null, basically. Nothing is gonna work. Like the identifier someth is not gonna get executed because it doesn't match the requirements of it, basically. So that is what this does when you have this after the curly bracket. It would make it so the identifier only gets executed when it's on the far left. This is only useful when you're when you want the identifier to be executed by itself and with nothing else, basically. So like something like like that, and I don't know, you could have some value placement there, I guess, like X as a value placement if you want. So this is gonna work because X is a value placement of it. But if I remove that X and then I do someth 1 2 3, this is not an identifier, so it's not gonna work because it doesn't match the identifier that I'm trying to work with. So this identifier has a value placement, and this one that I wrote doesn't have a value placement, so this is not gonna work. It's not gonna execute this identifier. Okay, and if you want an identifier to not be deletable, you can do that by adding the solid key before the right key. That makes it so when you try to delete it later on, like right here, the delete function is not going to be able to delete it because we create it as a solid key. And the only way you'd be able to delete an identifier is if it's not created as a solid and if you give it the correct ID. So the way you'd get the ID of an identifier is by using the ident as a function. So you call it as a function, and inside of that you put the identifier that you wrote. So in this case, if I wanted to delete the sum ident, I'm gonna copy identifier. I'm gonna copy that, and then I'm gonna put it in here. And now let me actually go ahead and look for the what ID this returns. So I'm gonna load. So as you can see right here, this is the ID of that identifier. I'm gonna copy it, and then I'm gonna put it right here. And then this decode function, it will actually decode the ID that you have. So if I copy this ID and put it here, just like that, and I save the code and reload, you notice that I get the same identifier keyword, which is someth, which is this one. So this ID on top is the same thing as this, and the only way you would get that kind of output is by when you're calling the decode function and then giving the ident : the ID that you're trying to decode. And the only way you'll be able to delete an identifier is when you call the delete function, put the ident key : and then the ID of the identifier that you're trying to delete. So yeah, that's and the only way you'd be able to get an identifier's ID is when you're calling the ident as a function, and then inside of that you put the the identifier that you created. So if and also if your identifier has a value placement like x, for example, you well, I mean, the name of the variable could be anything you want, but let's say that your identifier has a value placement. The way you'd be able to refer back to that into the has an identifier when you're trying to get the ID of it, you have to add the @ symbol and then the curly bracket after the @ symbol. So that's gonna make it so the it's basically a value placement. So you have to have that inside of the decoder, I mean the encoder, when you're trying to get like the ID of it. So that does that for us. I think there is like encode function that you could use. No? Okay, maybe I don't know, maybe you have to say ident, right? No? Okay. Okay, okay, I thought there was a function called encode, because there's a function called decode here, so I was like, maybe there's a function called encode. But no. Okay, so yeah, you call the function, and then after it, of course, you don't have to add that because it knows what this is. After the function, inside of that, you have the it's where you would write the identifier. And if you have a value placement, you don't have to. You're not required to put x there, like @x, because that's not how it works. You have to put the @ and then the curly bracket. And if you have another value like y or whatever, if you have another value placement, then you have to also add it here as well. So if I save it now and reload it, you would notice that the ID now has two @ symbols after it. Basically, that is the value placement. Those @ symbol represent two value placement. So you have to copy that and also put it in here. So if I do that, oh yeah, also you could log that out as well. It's also gonna give us like the value placement, which is the @ symbols. So as you can see right here, the @ symbols and the curly bracket. So those represent value placement when you see those kind of things, with an identifier. Yeah, that's really all, I think. Hopefully I explained everything. Thanks for watching this document. I'll see you guys on the next one.